Hi guys, today's video is about the tools of measurement that are used in epidemiology. The three tools that are used in epidemiology are rate, ratio and proportion. Now rate is as simple as asking a kid to tell me how many oranges are present in a total or in a basket full of fruits. So he's going to say that okay, there are 5 oranges in this total mix of apples, bananas, oranges and everything. So basically what he is doing is he's going to count the, like in epidemiology, if you have to apply rate, that is basically the number of events which are there in a specific period. So there is a specific period that is decided, so these many events happened, divided by the population at risk experiencing the event or disease into 10 raised to n, which is basically a multiplier. So this is your numerator, this is your denominator, this is your multiplier. Now the numerator also forms a part of the denominator in this case. For example, if I am going to a school and in the school I am going to check how many students are having caries. So this school that I have visited has 5,000 kids. Now in the 5,000 kids, when I examined the oral cavities, I found that 2,000 of them have caries. So I multiplied by a multiplier, say I multiplied by 1,000. So I am going to say that okay, out of the number of students, that is out of 2,000 students, since 5,000 students are having caries, the rate is basically 2,000 divided by 5,000 into 1,000, which comes to 400 per 1,000 kids. So per 1,000 kids, 400 of them have caries. Now why did I say 400 per 1,000 kids? Because the multiplier was 1,000. Now this multiplier is basically used for our convenience, wherein we don't want the number to be in decimal. So if I would have taken 2,000 divided by 5,000 itself, I would have got 2 by 5. So that's a very weird way of expressing the rate. That's why I multiplied it by 1,000 and then I said ki okay, if there are 1,000 kids, 400 of them will be having caries. That is the rate at which caries is prevalent in this school. Alright. So in rate, the numerator also forms a part of the denominator, because these are the same students who are having caries, right? Like the population, that is 5,000, out of these 5,000, 2,000 people are having caries. So that's why it is the rate, and in rate the numerator also forms a part of the denominator. Coming to ratio, ratio is basically expressing the relation in size between two random quantities. For example, the male is to female students in a dental school. So if it is a class of 100 students, say 20 of them are males and 80 of them are females. So that is the ratio. So you're just taking the two random quantities and dividing the two. So this is male, which is say the first quantity, female is the second quantity. So that is basically A divided by B. That is your ratio. Okay. So it is expressed as a result of one quantity divided by the other quantity. That is ratio. Next is proportion. So proportion is also like a ratio which expresses the relation and magnitude of a part of the whole. So for example, the number of children in a school with dental caries at a certain point is the numerator, and you divide it by the total number of the children in the school at the same time. So you divide it by that and you give it in the form of a percentage. That's why you multiply it by 100. So if the same example was taken and a proportion was found out, so for example it is 2,000 divided by 5,000 into 100. So 2,000 divided by 5,000 into 100. So that will be like 0.4 into 100. That is 40% of the kids in this school have, like the proportion, that is a percentage of them having caries is 40%, or 400 in 1,000 kids. That is also 40%. So that is rate and ratio and proportion. So what you need to remember out of this video is that in rate and in proportion. In rate and in proportion, your numerator is a part of the denominator, while in ratio, these two are very random quantities, so the numerator is not a part of the denominator.